Hi everyone, my name is Maina Wycliffe. I am a software developer for Skyhook Adventures. This is a UK company where we sell trips across the world. Basically, selling trips to tourists, connecting them to sort of what we call hosts. The idea being that if you have a trip near you, you're offering what we in Africa popularly call safaris, then you can connect with potential customers. Today's talk is about RxJS, and today I wanted to talk about reactivity. Basically, how you can connect multiple components within your Angular applications, and when you do action on one side, it reacts on another side. So before I can get to that, I want to just go over RxJS brief overview. For those who are not acquainted with it.
Wycliffe.
Yes?
I can't see your screen.
Sorry. Should be visible. Is that the case for everyone else?
From my end, it's okay. Anyone else who's having issues with probably seeing the screen?
Yeah, mine is okay.
Oh, okay. Anyone else maybe having some issue?
Mine is okay.
Oh, okay.
So is this still the same on your side, Ivy?
I still can't see your screen, but let me see. Let me try. Let me try and see.
Yeah. Not sure what the issue is.
Maybe she should try to join back in again. It's okay. I can see everything.
Okay. So I was just saying, I wanted to just look at a brief overview, nothing detailed, just the basics of Reactive JavaScript or RxJS. So ReactiveX JavaScript is the implementation of ReactiveX library. For those who are not aware of this, ReactiveX is a library that implements observable patterns across multiple languages, not implements itself, but rather brings in a number of guiding principles which other libraries like RxJS can take on and borrow and implement natively within that language. This is cool because it allows you to have some guiding principles for a specific implementation of an observable pattern, but having a native implementation for each language which is native to that language. If you take the implementation of RxJS and one other that I'm completely familiar with is RxDart and RxGo, the three are completely different in terms of how they are implemented. It feels native. For instance, in Go it uses channels, in Dart it uses features, and in JavaScript it uses what we have become familiar with the subscriber pattern, which is quite similar to the promise pattern. And this is the whole idea behind the ActiveX. It implements the ReactiveX library for that. So it's an observable pattern whereby things are streams of data, which are, let's say, a button click, HTTP call, or something else that's treated in a more functional way instead of the old way, which is a little bit dirty or a little bit more confusing or less readable. With RxJS, it allows you to treat these streams of data in a way that is easier to to work with, while not sacrificing readability. It's not ReactiveX is not specific to JavaScript. Like I said, there are implementation for almost all languages out there. I think I have seen up to 12. Not sure about that, but if you go to ReactiveX website, you should be able to see all supported languages, and more are being added every day. So let's look at the core concepts of RxJS, where we have the observable, which is a future value or event that will happen in future. And then an observer, which is the second core concept, can listen to that. So I give an example of a button click. That's an observable. And then an observer is a method that gets called whenever that button gets clicked, or a HTTP request. That's an observable. Whenever someone sends a request, an observer is waiting for a response. Then we have subscription. This is what triggers the execution of an observable. In this case, if you have an observer for a button click, and if you click 100 times and there is no subscription, the observable will not get executed. So those all calls get ignored, depending on whether it's a normal observable or a subject. Operators are pure functions which are used to transform streams of data, or in this case, observable data that's coming through. For instance, you can start with data from the server and then manipulate it to call another, to make another HTTP request and another until you get to the final request. And that way, and this is what today I want to focus on mostly, is the subjects. Subjects is just an observable, but unlike a normal observable like a HTTP call, it allows for multiple observers to subscribe to it. And a very good example of that is a button click or a button event, where a HTTP request is more of an observable, not a subject. And then we have schedulers, which control the concurrency and enable coordination of observables. So why should you use observables? The first thing is pure functions. And for those of you who are fans of functional programming, they know pure functions are easy to troubleshoot, easy to work with, don't have a lot of side effects. And this makes it harder to make mistakes. With an observable, whenever you transform data through a pipe, it always returns new data, not mutating the data that existed. Then you have the control flow of data so that you get that pipe, and then you can perform operations in sequence so that you are able to read it when you're doing that. I had a good example of this, but I completely forgot to include that. But basically, you use the pipe and then you list all the functions in the order you want them executed. And the results of the first functions feeds into the next function, into the next function, into the next function until the end. Then you have transform values, which is the same thing about operators, where you're able to manipulate data coming from a specific source. And then it's supported by multiple languages. Definitely this is an advantage because you have that for Go, you have that for JavaScript, you have that for Dart, you have that for PHP, Python, etc. So today I want us to focus a little bit more on subjects because that's the whole idea about reactivity. And subjects, like I covered earlier, like observables that allow multiple subscribers to, or multiple observers to subscribe to or to listen to. They maintain that registry where they're able to know when a subscriber joins, and they're able to notify them whenever something happens. And whenever they unsubscribe, the observer just the observer removes that from the registry. It's the observer, the subscriber, that is, the observer cannot distinguish between the two. They can only subscribe and subscribe to an observable. And observables get executed as soon as they are created, not unlike subjects gets executed as soon as they are created, not when they are subscribed to. Unlike an observable, a subject has the following methods. You have the next method. Whenever you want to push to notify the subscribers or the observers of new data, use the next method. Whenever there is an error, use the error method. And whenever you want to close the subject, use the dot complete method. There are three variants of subjects. That's the behavior subject. Today we work with that. There is the replace subject and there is the sync subject. The difference between the three is the behavior subject always replaces the last value that's in memory that was emitted. Well, the replace subject will replace all the values in memory. That is depending on the buffer size. So by default, it replaces all, but you can restrict that to a specific number so that it doesn't replay a lot of data. Async subject are like, well, promises, async promises whereby they behave like subjects, but only wait for when it's close to a meta variable. So here I have a demo, which I'll have to exit from the site so that I can show it. It's in just a moment. I hope everyone can see that.
Yeah.
Okay, let me just refresh that. Okay, this is basically a to-do application like we developers are already used to building. But in this case, I have expanded it so that I can demonstrate the powers of behavior subjects. So in this case, I have a component for searching. I have another component for statistics. I have another component for adding to-dos. I have another component for listing and another component for displaying the actual item. And the whole idea here is that whenever something happens in the, let's say, add to-do component, I can add a to-do. Let's say some to-do. I know, very creative. Then, and when I save that, the behavior subject basically notifies the listeners that there is a new list, and then forces a rebuild. And as you can see up here, the start level, everything is changing so that I can say, and the start change, I can do something like that. And now you have no ongoing to do, and the same when you do the opposite. It's not a complicated example, and that's why I picked it up, because it's simple to get to show the concept of observables or RxJS in general, so that you can see how they work. For instance, you can search. So let's say you want to search for all to-dos with by, and once you hit enter, it gets refreshed. So I want to take you through the code for this, every aspect, some aspect for this, and how you can use observables to make your components communicate very well. So I'll be going back to the presentation. So let's look at the component hierarchy of our to-do application. I know this is not convenient because I could have done this with probably 2 components or fewer components than this, but I just wanted to show the concept here. So we start with the main page of our application where everything is loaded, and we have a top bar component where the search component is housed at, and then we have the main page. I should probably have named that something completely different, where we have the add to do's component, we have the list to do's component, and the starts component. And then we have the list to do component, we have display to do item. And the whole idea is to tie all these things, with all these components with a behavior subject, so that when something happens on the search component, then the stats component react to it and display the correct information. In this case, when you're filtering the list. And the same goes for something like when you add a to-do, the stats component should update correctly, and when you mark a to-do as done, everything should reflect accordingly. So we are going to look at the source code for this, and I'll share the link to the repository and the demo at the end. So let's go on and look at the service. I'm going to assume most of you are acquainted with the basics of Angular, so that I can jump into talking about the service without going too deep into how Angular works. But the reason I'm doing this in a service is because services are synchronous. It means we have a single service running in the whole application. We don't have to, which means any data we put in a service during, let's say, construct or when we call a method, it's the same data that will be supplied to all components. So in this case, I have a property called to-dos with an underscore, which is a private property. And in this case, I'm just saying it contains a list of to-dos. I'm using this as sort of a data store. And this is where you'd probably not do this if you had a backend, but rather call that data and store that data from the backend in here. Then I'm creating a to-do data stream, which is a behavior subject of to-dos. The to-do in this case here is an interface defining the fields of our to-do. Doesn't do anything. So in this case, it's an array of that. Then once you initialize the to-do service, we are just creating a new behavior subject, and then passing the initial to-dos. And then we create a getter, that is the getter for to-dos, which returns the data stream. What this allows us is to basically say service.todos, and it returns this list of to-dos in a subject, and we can subscribe to it simply. So with that out of the way, the service is much bigger than this, but this is what we need to look at initially. We are going to be adding more components as we go, more methods and properties as we go. So let's look at how we are going to be listing to-dos. In this case, this is the listing to-dos component. So we are starting with the to-dos observable, which is denoted by the $sign at the end. And that's a convention in Angular. When it's an observable, you use a $sign at the end. And then on initialize of the class, when we initialize the class, we are saying this .to-do service, which we injected into our component using dependency injection at the constructor level, then to-dos.pipe. In this case, I'm just using pipe to console log. The tap operator in RxJS is used basically for things that don't return anything. So like in this case, console log. But you see some other observables, like some other operators like map, which I will use to do some of the statistics later. So in this case, I'm just assigning that observer to do this. And the reason for I'm doing this is so that I can use the async pipe from Angular to subscribe to our to-dos. But if you wanted, you can subscribe to that. The problem with this kind of observable is you need to unsubscribe to it, to unsubscribe when you are destroying the component. Otherwise, you will end up with a memory leak. Normal observables, like when you're calling a HTTP endpoint, you don't have to unsubscribe to that because that's a one-time to do. That's not to do a one-time observable. But in this case, this is a behavior subject, and once you subscribe to it, you get notified of all the data that comes in and can lead to memory leak unless you unsubscribe to it. So that's why we have the async pipe, which does that automatically for us. I think I have the next slide with the template for that. Yeah. So in this case, I'm just saying, take the to-dos observable, subscribe to it, and once the component is destroyed, the async pipe will just unsubscribe to that, so we don't have to worry about that. And then assign the resulting data into a to-dos variable. This is a template reference that now we can use within the Angular template. And then with the to-dos we have, we can simply do a loop over and display the to-do. I did not display the code because it would have been unreadable due to the amount of classes and other stuff that would have been it. I hope that makes sense. So let's take a look at how we can add to-dos, and in hindsight, this is one poor presentation of these two methods. Okay, on the bottom, which is where we are going to start, we have an add to do, which is a method that is within our service. I said earlier we're going to be adding new method. In this case, we are just taking the to-dos array which we had initially, and then concatenating with the new to-dos and returning that and assigning that back to the same, that is this dot to-dos. Of course, you could do something like push, use the push method to add that, or any other thing that does that, but it's up to you. But you should, this is also not the best practice for this, because basically you are mutating the data, which is against, which is not very good for state. And then once we have that, what we are doing is calling the next function or the next method of our to-do data stream and passing in the new updated to-dos. And what this does is it notifies our list to-dos component that there's a new to-do, and then it displays that. And one thing I should have mentioned earlier, let me go back, is that you probably should add a key to this loop. Otherwise, this content will get rebuilt every time something changes, or else only a small section of that will change. So having a sort of, I don't exactly remember what it's called in Angular, but it basically prevents it from getting rebuilt every time. So in our component, adding to do component, basically we just call that method at this dot to do service dot add, then pass in our to do, which has two fields. That is the to do, the to do itself, and if it's done. And because this is a new component, we are just saying it's not done. I don't know why you did done to do. It seems I have a duplicate left, sorry. Okay, let's look at to-do stats. In this case, it's where we took the list of to-dos we had, we displayed the total number of to-dos and displayed the number of done, the number of complete and the number of incomplete. So in this case, we are just taking the to-do data stream, then piping it, and then using the map operator to basically filter it and then find the length of the remaining number of to-dos. Basically, the count takes if it's done. So in this case, it allows you to check whether. Yes, Kevin?
I have a question, maybe before you proceed.
Yeah,
on the previous slide.
Yeah.
Yeah, that one. So well, you say that it's notifying the listeners of the new change. So are the listeners being notified because they have subscribed, or once that data changes automatically, like the listeners are notified? Like what makes it that easier for it to notify the listeners that there's been change in this stream here?
Yeah, it's because they have subscribed to the observable, that is this to-do data stream. So whenever a change happens, it notifies its listeners. So anyone who is subscribed to that, even if we had 10 components subscribed to that, in this case we have 3 components, all of them get notified that something has changed, and then they rebuild.
Okay. Yeah, I guess that answers my question. Yeah.
I can make further clarification if I didn't make myself clear.
So on the side of the component, because I was thinking that, for example, like what makes a behavior subject good is the fact that you can be able to get like a value when it's emitted and something of the sort. So I'm trying to understand how like the subscription is working, because I was like understood that once you have subscribed to an observable, because I guess here you are converting the behavior subject into an observable, then subscribing to it, right?
Yeah, okay. Behavior subject is a type of observable, basically. And there is no distinction between that with a normal observable. That once you subscribe to it, any future values you get notified of it. Unlike a normal observable where once you subscribe to it and it's done, it gets closed.
Okay, yeah.
Yeah, so in this case, we are getting the previous variable that was installed and also future variables until that time when we unsubscribe.
Okay, thank you. I guess I will get more clarity as we proceed. Yeah.
Okay, no problem. So in the to-do start component, this is in the service where I have added a method to count to-dos. It accepts an is-done method, which is a Boolean type and is true by default, so that if you don't pass anything, it defaults true. So in this case, we are just filtering the list of to-dos in our data stream and checking whether checking it against this done method that's passed through the argument to count to-dos method. And then what remains, we can do dot rank so that we can get the number of to-dos that are done or not done. So to use this, we basically just in our initialization of our component, we can basically say count to-dos, and when you want done to-dos is passed through, or false when you want not done to-dos. And then to count all to-dos is basically the same process we did earlier, but in this case, we are just checking the length, not without filtering anything. So this allows us to use a sync pipe to basically subscribe to our 3 observables up top, which I did not add the $sign, and basically subscribe to that and get the actual length of that filter to-dos, or in the case of all to-dos, or total length. So we are still subscribing, to make this clear, we are still subscribing to the same data stream, which is being used to make the list of to-dos, to show the list of to-dos. This allows, and that's the advantage of behavior subject. Multiple subscribers or multiple observers can be added as listeners, and whenever something happens, they all get notified. So when it comes to search, this is where I had to be a little bit creative, but it's still possible, whereby I take the current list of to-dos, and this is in the service, the to-do service, where basically I take the list of to-dos, our initial list plus any updated to-dos that have been added to that, and then filter to search for the term within that for each to-do. And because I don't really want to remove any to-dos from our data, from our total data, I just assign that to a variable x, and then I can pass that to x. I can pass that to the next variable so that it returns a new filtered versions of the to-dos. This allows you to basically manipulate the data and pass in variable without changing the underlying value. And basically this, once you hit enter, after you have typed in your keyword, the search happens, and the list to-dos component we talked about earlier takes over from there. So basically this doesn't have its own component. It's raised with a list to-dos component. So here is the search component, whereby, as you can see, I have a search control, which is a reactive form control, and represents just a single control. And then whenever someone hits search, it basically passes that value to the search method in our service. Something else that's quite important with to-dos is changing the status so that you can toggle through whether it's done or not done. So to achieve this, I added a toggle to-do status, in which case I pass the to-do that you want to change. Then I'll take that list of to-dos, which is our initial data, then map the data so that I can change the value of the one I want while also retaining the origin of the value I don't want. In this case, I'm just saying if our to-do doesn't match that, then return the initial the to-do. Otherwise, if it matches that, then return that to-do, but modify the is done property so that it's the opposite of what it was. This allows us to basically change the done to do to not done and the opposite, so that whenever you click once, it's done, and once you click again, it's undone. And then the resulting to do, basically because we want to mutate this data, we change that property, the to do's property, which contains our lead data, and then pass that data stream, or to, tell the data stream to notify all the listeners that we have a change in value. So this inside our component for displaying a to-do item, we have this model called toggle to-do status, and basically calls this .to-do service.toggle status. And then our template looks like this, where we have a click method on a div or container, which probably should not do unless you're doing tutorials. Basically, once you click that method, it calls that passing out to do. So that's all the component we had, and basically that's what allows us our component to basically. Let me switch back to the display to the demo back again. Let's refresh that. With all that function, that's what allows our component to work as it is, so that once I click on to do, it gets marked as done. Once I click again, it's not done. It toggles the status. So I can add new to-dos. And whenever you add that, this adds to that, and then notifies all listeners that there is a new to-do. In this case, I need to update this list, and also need to update this statistic, so that whenever you add a new to-do, it adds a new to-do here, increments the total to-dos, and then you have an increment in ongoing to-dos. Once you mark a to-do as done, it decreases the value here and increases the value here. And once you do the opposite, that happens. The opposite happens. I hope this the whole idea of today's talk was to show you what you can do with the behavior subjects. So what you can do in with RxJS in your application, so that you can build a very reactive application that does things in a much cleaner way, while also avoiding state management, because this is the basics of what state management works under the hood. Okay, not as simple as this, but takes it a little bit further, but because you have concepts like immutability built in. But other than that, these are the basics of state management. You don't need to implement state management for you to come up with an application, especially a small size application. You can get it to work very reactively without implementing something like ngrx, Akita, ngxs, mobx, or etc. So I'm going to be sharing the slides, which have a link to the demo. I can also put the demo. I think I can put the link to the demo in the chat. No, I can't. Yeah, I'm going to be sharing the link. I will share that on Twitter. Follow me. You can follow me or follow Angular Kenya, where you find also the link to those. And if you have any questions, I'm open right now, and also you can reach to me in future for that.
All right. Thank you, Wycliffe. Thank you for that amazing session. Well, the thing is today was just to do a brief intro on what, like the capabilities of RxJS with regards to you building your Angular apps. And yes, it may not be like a lot of hands-on like coding and all, but it's just like a brief intro to show how the code looks like, touching a bit on how you can use listeners for such. And if anyone has question, please, you can just unmute or just raise your hand and then unmute yourself and just ask the question. Any question, please ask.
So, hi, Wycliffe.
Hi.
So maybe one question that again I have is, so when do you decide, like what can, or rather in RxJS, like having a look at the all the observables that we have, like what do you think somebody should consider, like when he wants maybe to implement something with a behavior subject, like is there, or maybe a subject, or just saying that I want this is an observable, is there like a certain need case that you feel that is mostly being implemented? For example, like in the case of a behavior subject, is it so, like is there a need case that you can say that mostly behavior subject is used because maybe somebody wants this and this is where a subject is good and this is where you need it? Like, is there that disparity, or it's more of they offer the same functionality but it's just what you choose to do?
Yeah, so you mean what's the key difference between a normal observable and a behavior subject?
Yeah, and yeah, I think, yeah, and maybe like the especially in terms of the use case.
Yeah, in terms of normal observables have a limitation in that once you subscribe to that, something they get unsubscribed to. So let's think of a situation where you have a button in your site that whenever you click it, something happens. For normal observables, once the first click goes and the subscriber gets the data, it gets closed. But with a behavior subject, you can always notify the subscriber or multiple subscribers whenever that happens. Another advantage behavior subjects have over normal observables is the ability for multiple listeners to come in and listen to this. And this comes into handy when, let's say you have a HTTP call that multiple components are going to use. So you can make the initial call and put that as a behavior subject, and other subsequent calls get the last data of that call. This enables some nice functionalities such as polling. Like for instance, when you're doing notification, you can either do that with WebSockets, which is not always possible, or you can do with polling, where you basically check for notification every, let's say, like 1 minute. If you had multiple components basically relying on that data, it would allow you to basically subscribe to that, to call that, to make that HTTP call once, and then use it as many times as the subscribers you have. So yes, a behavior subject is not always the best choice, because in some cases an observable has advantages, because like when you're making a HTTP call. But it also has its own use case in that when you want a long running observable that future members, once they join, they get the latest value and then future values as they come in. I think another good example we can think of is like voting, where multiple people are voting at different times, and you want to display like a sort of a dashboard. And this is simplified. I have to add that, very simplified, but I hope you get the idea. Whenever someone votes, you want to update the dashboard. And that's a very important use case for a behavior subject. Yeah, basically, whenever someone joins in, they get the latest value, that is the latest total vote count, and then new votes as they come in. I hope that answers your question.
Yeah.
Okay. Anyone else who has a question? Okay, so probably this could be a question that I personally have. So so you say that for this demo purposes, you are not working with the backend. So what if you had a backend? How would RxJS come into play?
What you normally do is take make a HTTP request at maybe a constructor level to get the data you want if you know it up front. If you don't know it up front, you may basically need a sort of a method to do that. And once the data come in, instead of returning that one-time observable, you can add that data you can add that stream to an observable which you can stream separately. So instead of having so that you have sort of like a subscription that does that's the view of the data, and another one that you subscribe to for one-time data cost so that you can refresh to it. You can also use pipes to basically transform that one-time observable into that basically a behavior subject so that it can get subscribed to multiple calls. But it mostly depends on how specifically you want to architecture your system. So the best way is to basically call the service and then store that data into maybe a variable in the service into another variable that or notify the listeners of that observable, so that you can say .subscribe then .pipe on, then use maybe the tab operator. So say whenever the actual data comes in, basically run something like this data stream.next, passing in the data. So then instead of subscribing to that method, you still need to subscribe that because an observable gets executed once you subscribe to it, but other subscribers listening to that data will get notified. That is the behavior subject that is a property of let's say, a service.
All right, thank you. Anyone else who has a question with regards to this? Okay, take that as a no. All right, I'd like to say a big thank you to Wycliffe for joining us for this call and giving us a brief intro into RxJS with RxJS. Wow, I keep on mumbling these words. RxJS with Angular apps. And please feel free to at least explore some of these capabilities, because the reason why we have this course is to give you kind of like a sneak peek into what Angular is all about. I know most of you here are beginners and are just trying to get to really understand how Angular works. As usual, you can either reach out to us via Twitter, you can add us, and we'll try and answer your questions. Also, you can consult the angular.io. That's the documentation of Angular, which you can get pretty much everything that you might be looking for. At the same time, we have a lot of YouTube tutorials. We'll try as much as possible to also share any resources that we find useful for beginners. Without much further ado, I'd like to say thank you once again to Wycliffe, and for you attendees who took their time to attend this session. And we hope that you've learned something, at least a thing or two from this session. Next week, we're going to have another session. We'll definitely provide you details. If you haven't followed us, please follow us on Twitter. That's where we distribute most of our communication. And we provide you with the links to the call via emails after you RSVP for this session. So you find out that we might not share these links like during the RSVP session, because we feel like we really need to have some sort of like decorum, if I should say, because sometimes you find people Zoom bombing calls and all that, but we're trying to make sure that we have calls that actually make sense for everyone. Thank you guys for attending this session, and this video, I mean, this call was recorded, so we'll definitely convert it into a YouTube video, and then we'll share the link with all of. And if there's no question or no comment, no remarks, I'd like to put an end to this meeting. And thank you all for coming. Thank you, Wycliffe. If you have any closing remarks.
No, I don't have any closing remarks. I should have thought of that.
All right, no problem, no problem. All right, guys, thank you very much.
Bye. Thank you for attending my talk.